70s, 80s, 90s on the test. Are you already recording?
Yeah.
I'm really dead. But you already pulled 70s, 80s, 90s on the test. So, if that's you and you want to raise your grade, you're the person I really want to see come to tutoring today. If you have not done any kind of learning by the time you come to tutoring today since yesterday, then why are you coming? You're just guessing, okay? So a lot of times when I give retests, I see test scores go down. And I just wind up keeping the highest one. But in reality, the district sees your newest grade. I see your highest grade. Okay? So you're making me look bad because you ain't learning.
Wow.
All right? Now, I have reviews and things up. I got the videos up. I'm actively recording. I am out here. Okay? I got iMovie. I got a swivel. It's being held up by the Stanley. That's actually a genius idea. So, I have the resources for you. You got to do the work. And every class is going to hear this today. You got to do the work. Now, like I said, some of you did the work and it didn't work out for you on the test. And that makes me wonder, did you pay attention during the review? Did you work through the review? If you didn't actually sit down and do the review as if it was its own assignment, then you can pinpoint why you got the grade that you got. And really, that's for everybody. Okay? Now, I also want to remind you of this. If your test grade is higher than your puzzle piece grade, then I will put the test grade in for every single puzzle piece grade as long as you actually attempted it. So some of us attempted all 4 puzzle pieces, and like 3 of us actually did better on the test than on the puzzle pieces. So I then put that, let's say they got an 88, 88, clean, all the way through all the puzzle pieces. Because you demonstrated that you know an 88 level of understanding on every concept. I'm cool with that. But if you did not turn in a puzzle piece, and then you did well on the test, you still got a 50 for that puzzle piece, because I never got work from you. Okay? That's not fair to have you just sit there and then boom. All right? So, I need you to complete the work. You need you to complete the work. Some of us got 5 50s yesterday in a row. I've never given that many like that. And your numbers, with every 50, that 50 holds and that average gets stronger. And it's going to take more from you to come back from that. A 50 looks nice. It's not a 0. But 5 50s, that's strong. That's going to take several 100s to overcome, or you need to go back and fix it. You can do that. Okay? So, that's the numbers game, that's the test game, that's what we're talking about with that. Are there any questions about that? All right. Can't hear you.
What are you filming?
I'm filming
Okay, teachers and staff, at this time, everybody should be in first period. Teachers, they
Wow.
can this morning, at this time, if anybody comes to class, it'll be
On those glasses featuring, oh, tough.
Where'd Mr. Teacher go? I'm just kidding. Wait,
Filmographer, are you recording on like 4K or anything like that?
No.
Okay, because that's a really big file and I don't need the space, so thank you.
I'm just videoing on video.
Yeah.
Okay.
And so did iMovie finish downloading? Or is it, okay.
Yeah, I know it's.
We'll edit that out.
Great.
Hey, Jair, did she pick up y'all's paper yesterday?
All right.
Oh my gosh. Mr. Shannon, please look at what Jair just wrote on
I
his
know,
paper.
he's putting his ads. I know. That'll be blurred out. Thank you. Actually, no, I'm gonna do that.
Phobia.
Phobia. Mr. Shannon, say it.
What? Phobia.
Okay, fine, I won't promote myself. I'll promote something else.
I have a question, Mr. Teacher.
Yeah.
So, say we were to do our puzzle pieces already.
Yeah.
Like we finished them.
Yeah.
There's 50s in the grade book because they were done after you put in grades.
I'll remove it.
Great, thank you.
So the way Schoology works, and y'all need to hear this one more time, so listen to me. The way Schoology works is I put a 50 in if I don't have it, right? Well, that creates an override. The puzzle piece is still open after that point, but your grade in Schoology is going to remain a 50 until I go in and remove the 50 override. If you want to know the actual grade you got while there is an override on your puzzle piece, just hit the view button after you submit. And it will actually tell you how many questions you missed, and then you can see what your grade is. But it's going to remain whatever that override grade is until I clear it. Okay? So I put 50s in starting yesterday, which means from now on, if you reattempt anything, it's wise that you tell me and or send me an email. That way I know I'm looking for it so I can remove the override. Because the last thing you want is to do all the work and you didn't tell me about it and I didn't see it, and then your 50s sit there even though you've done the work. So just let me know. And I'm really showing out today because I'm on video, so what can I say? I'm good under pressure. Let's get this done. No, thank you. Hey, no free advertising, okay? No free advertising.
It's not free.
You're gonna have to, if you want to appear in my video, you're gonna have to pay me for video time. You understand?
You for where's my person? I don't have to be in this class.
Oh, you don't. Let's see. Let's see how long that lasts.
I'm running one more ad. Oh my god, you can be like, no, we'll be right back up this short ad.
I say that my videos are made for kids, so there's no ads that are possible on that.
Your videos are made for kids.
Y'all are children. You're since y'all are minors and you appear in the video, I say, yes, this is made for kids. That way I don't get people coming after me.
Okay, great, cool.
Okay.
Check your grades.
Also, this is a public setting, so you are allowed to video without consent.
I am, but I'm not allowed to post without consent.
You have mine. Wait, do you have to have consent for my mom?
Yes. However, this is a private video available only to my students, so now I don't need consent anymore.
Cool.
So if you want me to get famous, sorry. This is only available to my students.
We're talking about the enormous size. Yeah.
Yeah, she said that was an old homework.
Today was a day.
Do y'all have pencil grades?
Wonder why. I could not sleep. Guy's face and he has a mustache.
So this is us doing our work.
Oh my god. DARKE.com.
We're doing work. This is Mr. Shannon's classroom. These studious people doing studious stuff. Mr. Shannon.
What's popping? That's getting edited out.
Why?
Because this is so kids can like catch up on material, and this section right now is just dead time. They're gonna be.
This is Jair's ugly setup and Katie's beautiful breakfast, and we don't really know what she's doing. Oh, taking notes. Studious. TikTok. Daniela, what are you doing? Taking notes like a studious student. Bianca, balling. I don't know. Don't know. Jair! Ah! I just got pushed. Alright, everyone. The flip, do I look like a nerd?
Watch your language on my video.
So sorry, sweetie pie.
Okay.
Huh?
What?
You have scissors and glue?
Over there. I ain't got no glue, and I don't know why you're gluing in my class.
Do I have a weight test? Yeah, I think so.
Okay. Today, I'm also going to launch Unit 9. And Unit 9 has, since it's not on my board yet, 1, 2, 3 grades, plus 4 will be the test. Okay? Now, this folder, Stoichiometry and Percent Yield, has 2 grades tucked inside of it. Because it's 2 completely separate what was it saying? Concepts. Thank you.
You're welcome.
Now, for this unit especially, I have so many YouTube videos, it's not even funny. so that you can learn. And these are YouTubes not of me. So you're learning from the best of the best. Not only do you have some of the best YouTube videos, you got the best in-class instruction you're going to get.
How much time are you have on this one? This last one we have like 8
This
days.
test is on February 6th. I have not yet calculated how many days that is.
That's like 3.5 weeks.
Yep.
Actually, that's
Yep. Yep. So, but Pete, my friends, only 2 PowerPoints. So if you actually take my advice and get started on your notes aggressively, you have plenty of time.
No, I wouldn't say aggressive.
We're going to start here, 9C stoichiometry. And I'm just gonna, this is a brief overview, okay? Because everything is right here. This is 12 slides in this, including a title slide and a reference slide. Come on, y'all, it's 10 slides. Give me 5 a day, you're good. Give me 5 slides a day, you're good. How hard is that?
It's difficult.
Stoichiometric calculation. So stoichiometry. Stoichiometry is a big, crazy, scary word. Say stoichiometry. Good. Now stoichiometry is similar to a recipe in cooking. It's like we're cooking with chemicals. And it's like we've got recipes for chemicals. So here's what it's like. Pretend you have each ingredient and you need to make a specific product. So pretend you have a cake and you've got a specific amount of flour. But oh no, I want to bake 15 cupcakes instead of 6. And so I have to double the recipe, but a little bit more, right? Like double would be a dozen. So if I have 6 cupcakes, but I need to make 15, I've got some calculations to do, right?
Yeah.
So those calculations include every single ingredient. I gotta do about 1.5 or 2.3 on my flour, about 2.3 on my sugar, about 2.3 on my vanilla. Everything has to be changed, but it also has to maintain its proper ratio to each other so we got good tasting cupcakes.
Is that why cupcakes don't taste right?
Yeah.
I mean, to me, every cupcake, the fact that it's a cupcake, it's gonna taste good, but
Because like if I'm doing more than what it
My
says,
family
I
has
just
diabetes.
overfill the measurement.
What does that say, Bongo?
Oh, you want water? Okay.
right.
And then
So-
you
Not
have
spelled.
another 2 cups.
So especially in medicine and in industry and in engineering, you need to know how much you're going to put into something. You need to know what kind of product you're going to get. And you're almost always going to be making new products out of your products. You know what I'm saying? Like first we gotta synthesize the sugar together at this plant, then we gotta put it in this bag over here, then we gotta, you know what I'm saying? So it's a lot of process, it's a lot of downstream stuff. Stoichiometry is using dimensional analysis and the mold and balanced chemical equations in order to relate substances to each other, okay? So this says we use it to predict the amount of a substance needed or produced in a reaction, and that is very important. Now, the mole to mole ratio. This is it right here. Let me, you know what? Let me turn this off and teach you something for real, for real.
No way. I haven't gotten that
Yes.
type of treatment before.
So I'm going to build this from the ground up. This is about a year of chemistry, just conceptually, within a couple minutes. Now, up to now, I'm going to start all the way at the beginning with dimensional analysis. Up to now, remember, 1 divided by 1 equals 1. 2 divided by 2 equals 1. So what are we doing here? We're canceling out numbers, right?
Yeah.
Then I taught you, did you know that you could do apples divided by apples?
Yeah.
What is apples divided by apples?
Apple. I mean 1.
It equals 1. Apples cancels out. So that I can say 4 apples over 2 apples equals 2. And that's it. My units canceled. Okay? So we built up from there and we did dimensional analysis with conversion factors. So now I can say like, 60 seconds equals 1 hour, and 24 hours equals 1 day. So now I can say 3,600 seconds. I need to turn that into days, so first I have to go through hours. So I have seconds to cancel, so that's 60 seconds. Ooh, that's so wrong. 1 minute. And then 60 minutes is 1 hour, and then 24 hours is a day. Okay, so seconds divided by seconds is going to convert my unit to hours because seconds will cancel out, right? We've done this. My fault, thank you. I am tripping. And then minute to minute here, so now I need to go to hours. 1 hour is 60 minutes. And then I need to go to days. 24 hours is 1 day. And so see what I'm doing is I'm multiplying and dividing both numbers and units. And the way I was able to do that was this conversion factor right here. So minutes will cancel, hours will cancel, and we're left with days. You learned that too. Then we learned doing this same process, but this time we're doing it with a mole. Okay, so we learned that a mole is kind of here in the middle, and we can use the mole to convert back and forth to different things. You remember that? The thing we just tested over? So that 1 mole is equal to, in liters, it's 22.4 liters. In molecules, it's 6.02 times 10 to the 23rd molecules. And in grams, it's the molar mass of any substance.
That's where I went.
Yeah, that's where a lot of you got that question wrong, okay? It was multiple correct answers, and you had to tell me which of the following equal a mole, okay? And it had to be all of these quantities. And so what we did was we learned first how to go back and forth between each branch of this map, right? That was 8A. And then we learned how to go back and forth between 2 different branches, but we had to go through the mole to get there. Kind of like we cannot go from seconds straight to days. We need to have a middle step to get us from minutes to hours and then hours to days. It's the same thing. Okay? And so a problem on that one would have looked like this. We need to go back and forth, let's say from molecules to liters. So let's say we have 150 whatever, 1,500 molecules. We need molecules to cancel, so we drag that down here. And we use Avogadro's number to get us to moles. And then 1 mole will cancel, and then we can convert to liters, 22.4 liters. And now we've gone from molecules through the mole to liters. Seen that, right? Well, that's what we've done up to now. Now, we're adding another step. Okay? Stoichiometry is adding another conversion factor so that we can do more converting of substances and their units. But now, before we did numbers converting to each other, then we did units converting to each other, right? Now we are doing one substance converting to another substance. So every problem up to now, this would have said molecules to liters, but only of carbon dioxide. Or molecules to grams, but only of oxygen. Now what we're doing is molecules, liters, or grams of oxygen converting to molecules, liters, or grams of a different substance like carbon dioxide.
What?
Yes, what indeed. Here's how it works. Let me erase everything we've done so far. Up to now, you have learned This is called the mole map. You have learned this mole map. Let me erase this just for clarity. And you have learned mole of substance A. Now, using a conversion factor known as a balanced chemical equation, we can convert one substance to another so that we convert moles of one substance into moles of a substance B. And then we can go from moles of substance B, now we can do liters of substance B, molecules of substance B, and grams of substance B. So in order to get from moles of one thing to moles of another, I need a balanced chemical equation.
Also, like from the one of the earlier.
Yes, from one of the other units. So this is why we learned different kinds of reactions and how to balance them. I need a balanced chemical equation, and I got to come up with one in my brain. Here's one. It probably Mg plus Cl goes to Mg Cl2. Okay, so now I have a balanced chemical equation. I have magnesium combining with chlorine to form magnesium chloride. And remember, in the other units we learned how to name all of these things. So everything we've been doing has been building up to this. Well, now, what you're going to learn with stoichiometry is if I have 22 grams of magnesium, how many molecules of magnesium chloride am I going to be able to form? Not quite. Let me show you how this works. So our coefficients here, since I had to come up with it on my brain, are all going to be 1. But we've seen several chemical equations where the coefficients weren't 1, right? Okay. So, in order to answer that question, let's say 24 grams of magnesium equals how many molecules of magnesium chloride? With stoichiometry, I can figure this out. So first, let me change colors.
How did this get a type?
So first, my given is 24 grams of magnesium. So I'm going to do 24 grams of magnesium in my top left corner of dimensional analysis. Now, I need to go from substance A to substance B because I need to go from magnesium to magnesium chloride. So this is substance A and this is substance B. And then I need to go from grams along the way into molecules. So my travel on this map is first, I need to go from grams of substance A, grams of magnesium, up to moles of substance A, moles of magnesium. Then I need to go from moles of magnesium into moles of magnesium chloride. Then I need to go from moles of magnesium chloride to molecules magnesium chloride. Those are the 3 steps I'm going to be taking. My conversion factor up to this point, start here. Molar mass into moles means I need 1 mole equals the molar mass. I need the molar mass of magnesium. The molar mass of magnesium is, I think, 24.305.
Yeah.
Genius. Let's just call it 24. 24 grams of magnesium. That's going to convert to moles of magnesium. The number has always been 1 mole here goes to 24 moles of magnesium, okay? Now, I am here. And before, we would go here or here. Now we're going here, which means my conversion factor is my balanced equation through what's called the mole-to-mole ratio. What this means is this coefficient of magnesium equals this coefficient of magnesium chloride. Okay? This coefficient here can be used as a conversion factor to get me here. So I can literally say 1 mole of magnesium, because of my balanced equation, equals 1 mole of magnesium chloride. Well, that means I can convert from moles of magnesium to moles of magnesium chloride because of this balanced equation. So, if I'm in moles magnesium here, I can do moles magnesium down here. Do not get confused. I can take whatever this coefficient is, so let us pretend that this is 2, this is 2, and this is 3. That would be unbalanced, okay? But it's a janky equation in the first place. So let's pretend that this is how we balanced it. Here's what I would do. Moles of magnesium, I have 2 moles of magnesium now equals 3 moles of magnesium chloride. So to convert from moles of magnesium, I pull in the coefficient, 2 moles of magnesium down here, converts to 3 moles of magnesium chloride here. And now I have converted, I've gotten grams out of the way and moles out of the way, but now I'm in a new substance. Now I'm in moles of magnesium chloride. So from here, I finish out moles of magnesium chloride, drags down here, and 1 mole of magnesium chloride, I need to get to molecules, so I'm here now, equals 6.02 times 10 to the 23rd molecules magnesium chloride. And now those units cancel, and I have successfully converted not only between units, but between substances because of a balanced chemical equation. And this step right here is called the mole-to-mole ratio. And technically speaking, the mole-to-mole ratio is the only thing that's new. You have done this step already, and you have done this step already. But now it's realizing that you can go from here to here because of a balanced chemical equation. And you can turn grams of one substance into moles of that substance, and then go from moles of that substance into moles of the new substance. Again, I changed these coefficients so that you could see we're not just blanket blindly putting 1s here in this mole-to-mole ratio. You will always put a 1 here as your conversion factor within that own substance's mole map. 1 mole will always equal the molar mass. 1 mole will always equal 6.02 times 10 to the 23rd. But whatever your coefficients are for your balanced chemical equation here, that's what you're going to fill in for your mole-to-mole ratio. So that now, after I do all of these calculations, I'm going to know exactly how many molecules of magnesium chloride are going to be spit out based on how much magnesium I put in the first place. And that is where the money is made. Because you need to know how much reactant to buy in order to get a certain amount of product. Make sense? So, to finish this out, I would put this into Desmos, and you already know how to do this. We multiply across the top, we multiply across the bottom, we divide at the end. So that it looks like 24 times, just for clarity, times 1 times 3 times 6.02 times 10 to the 23rd. All divided by 24 times 2 times 1. When I put that into the calculator, it's going to spit out my answer in molecules of magnesium chloride. And that is stoichiometry. Again, the only new part is the mole-to-mole ratio right here, which I explained in my notes and which I've just shown you, starting all the way from the beginning of the year. So with that understanding, you can now go into the notes, give me 5 to 6 to all of them, slides worth of notes today so that you can continue to move on and start getting these puzzle pieces done. If you still owe me work from an older unit, why not take this understanding and apply it to the older unit on your own time? Let's raise those grades. Let's get it done. Thank you for watching. Don't forget to like, comment, and subscribe.